Okay, I haven't posted the original question here, but here's a summary. We've got a circle centered at the origin, radius r. In this case, I've labeled it A, and x sub 1, y sub 1 is any point on the circle. And if we create the tangent line at that point on the circle, and then pick any point on that line, what happens to be true is that the product of the x coordinates plus the product of the y coordinates of these 2 points will always equal the radius of the circle squared. Okay, and one way to show that is to use the Pythagorean theorem because, of course, the radius is perpendicular to the tangent line, the point of tangency. So we've got a right triangle. So a squared plus b squared equals c squared. A squared is the distance from the origin to x sub 1, y sub 1. That's this distance right here, but I've got to square that. And the distance from, I'll call this point P and this point Q, distance from P to Q is the square root of the change in x squared plus the change in y squared. And that's equal to the distance from the origin to point Q, which is square root of x sub 2 squared plus y sub 2 squared, but we're squaring that. So if we actually square each of these distances, this is the line that we end up with. Notice right away that the x sub 2 squared and the y sub 2 squared cancel out on each side. And then if I take these two terms with the minus signs in front, transpose them to the right side, which now has a 0 on it, and combine the x sub 1 squareds and the y sub 1 squareds, this is the equation I get. And you might notice that every term is divisible by 2, and that this expression right here is just the radius squared. So this is another way to show that from the point of tangency to any other point on this tangent line, the product of the x coordinates plus the product of the y coordinates will always equal the square of the radius of the circle. There you go. Hope that helped. If you have any questions, post a comment.